All right, well, welcome to Show Me the Compliance. My name is Kyle Harper. I am a lead engineering manager within CERNER's CERNERworks engineering organization. And today I'd like to share with you some of the journey that we took into compliance as code and some of the lessons that we learned along that journey. On our agenda first, we'll talk through security controls in U. Why does this matter? I'll share a little bit of our compliance challenge, the issues that we were seeing in front of us. Ways that we found compliance as code helped unite dev, sec, and ops. Some tips and tricks we learned while codifying the compliance. And then ways we've been exploring orchestrating that at scale. And then some lessons we learned to help better prepare your auditors. And then lastly, we'll come back and see how compliance as code helped meet our need. So to begin with, I'd like to talk through security controls in U and why do we care? And actually, if you've seen my ChefConf talk last year, some of these slides may look familiar, but I think it's absolutely worth reiterating. CERNER, as stewards of healthcare data, have the utmost responsibility to continuously respond to the evolving security landscape. And frankly, it's the right thing for us to do. The data is incredibly valuable. Depending on what research you look at the medical records can be worth anywhere from $50 to $250 per record, which is actually surprisingly higher than many other forms of information that we often associate as being high risk. So I'd encourage you to understand the value of your data and the value of what you're trying to protect. And breaches cost businesses an average of $11.7 million per year. This is according to the Pondman Institute in Accenture and the research that they did in 2017. And 46% of companies were left with a damaged reputation and brand value after that breach. The reality of the matter is that reputation is priceless. Unfortunately, we've all been probably subjected to one form of data breach or another. And think about how you felt and how your relationship with that company changed as a result of that data breach. And then imagine that if that was your medical data. So we really have a high burden, a high standard for us to meet. And lastly, sometimes we simply have contractual obligations to be able to implement security controls. These controls often are kind of coalesced and gathered together in something called a STIG, a Security Technical Implementation Guide, that you'll hear me refer to several times throughout this talk. So I'd like to share some of the compliance challenge that we saw in front of us. And a lot of this was growth into federal space, but the best practices that we're applying there, we've also been applying in our other commercial spaces also. So we set about some requirements for ourselves and an audit tool that we wanted to use to be able to validate our compliance. First, it must meet or exceed the security posture defined by the DISA STIGs and their security requirements guides. It must be literally as good as what we're contractually obligated to. We wanted it to provide a framework to be able to check what we tend to call manual findings, things that are beyond what can be automatically checked. SCAP, or the Security Audit Content Automation Protocol, is a common tool out there that can automatically check a lot of controls. But what we found is that it doesn't have complete coverage. So for example, in Red Hat Linux, it can scan about 3/4 of the controls, but the last quarter are left up to humans to manually interpret and check on their systems. We wanted the tool to be able to produce results compatible with the federal STIG viewer, and this is simply because this is the tool that they're using to view these results, so they needed to be able to ingest it that way. And it also needed to be ingestible by some proprietary vulnerability databases that we have here within CERNER. We needed it to be customizable for kind of variation in product implementation. So same piece of technology, but slight tweaks to how it's implemented. The auditing tool needed to be able to accommodate and handle that scenario. We wanted it to integrate into CI/CD pipelines so that we could help shift that compliance testing to the left. And lastly, we needed to be orchestratable across large port platforms and to be able to remotely scan target systems. So scale really is a common theme here. We are coming from a world where manual auditing was not uncommon, where for some of our legacy products, it was feasible to manually dial into systems and grab screenshots and try to gather data that way. But particularly as we explored and expanded further into our newer cloud products, it simply was not feasible. So for example, for 2 of our testing products, we estimated there would be about 50,000 manual checks that a human would have to perform. So we figured it would at least be 5 to 10,000 man hours of checks. And even for the sake of argument, we tried to do that. The risk of human error really is high in that evidence gathering, right? This is a very repetitive task, very toil-centric. And despite best intentions, humans are going to make a mistake either in their interpretation or in the mechanics of gathering that. And then the artifact management of that gathering is quite laborious and complex. How do you gather screenshots? How do you coalesce them? How do you deliver them? It gets quite messy really quickly. So as we started going into compliance as code with Chef Inspec, one thing that really was astounding is how much it could help unite DevSec and Ops. And a lot of that is due to the fact that it's readable by machines and humans, which was really empowering. In that, it's really a universal language. And this common language really helps enable collaboration between Op, Dev, and security. We found this to be particularly beneficial if we didn't have those roles in a cross-functional team. So if they were on different teams, different organizations, compliance as code gave us a common language for us to come together on and have a conversation and make sure that we are in agreement on what is the ideal security outcome. And a lot of that is due to the transparency that we do get in compliance as code. I like to think that it inherently self-documents the outcome, right? It clearly articulates your desired security posture. And again, it's readable by humans. So even someone who may have not been part of the creation of that compliance as code, after the fact, particularly when they're being held accountable to it, they can go look at it and really understand what's being asked of their systems or applications. So for example here, I would argue that even someone who may have never seen compliance as code probably can look at this and have a pretty good idea of what this Inspec is describing, right? In this case, it's asking that there's a ClamAV package that should be installed, and this version should equal 0987, right? It also wants the service to be enabled, to be installed, to be running. In another example, the Apache configuration, this max clients should be 100. It should be listing on port 443. Even if you're not really familiar with Inspec, I would argue that one can take a look at this and have a pretty good idea of what's being asked of the system. One thing that's been really powerful is how these compliance as code helps produce versioned artifacts of our security posture and of our state, right? In a sense, this is a snapshot in time that you can very clearly move from and to. So for example, as the STIG standards evolve and as they do, we can produce a version security artifact that represents that standard. And then our stakeholders can consume those specific versions and they can understand their transition from one to another. So they can have very intentional implementation and adoption across our enterprise. So we can see what standard someone might be met. Are they 2 quarters behind? Are they caught up? And things like that. It provides a very almost an immutable object for us to work with to encompass the entirety of that security posture. We've also found it incredibly useful to help source control the code compliance. Like many other things, source control provides a great mechanic and a place to have spirited debate. I love a good technical argument. And by having a source control, we really can have the thoughtful consideration that we need and bring in the necessary parties to make sure that these changes and that the security posture articulated in this code is our ideal security outcome. We've also found it a great way to help foster an internal community, so we can pull in a lot of diversity of experiences and expertise to make sure that we are getting the ideal compliance code. The source control also can help serve as a control plane to be able to enforce various processes and policy, including granular permissions. So for example, we have lots of various Inspec profiles and we're able to give contributor access to very specific people based on their expertise and be able to control that, the degree with which they can contribute to. We've also found it to be a great opportunity for a maintainer versus an owner. And the distinction I make there is I like to think of an owner as someone who is kind of the sole or primary contributor. It's their responsibility to make that, to continue to produce that, versus a maintainer who is really more providing more oversight. They probably are still contributing, but they're there to help review the code and ensure it meets the highest standards. So for my team, we have done a lot of Inspec production, but there's no way we could possibly produce all the Inspec that Cerner needed. So we've had lots of help from other teams. But as the maintainer of Inspec, we've been able to ensure that the code standards and patterns that we developed are maintained and held to the highest standards. So as we've begun to codify the compliance, I'd like to share some of the best practices that we've learned and actually creating the Inspec, if you will. First is, and utmost probably, is to treat security compliance as code like product. Treat it like any other piece of software that you might be developing or potentially selling. And leverage the best practices that you can have in agile software development. Very much create a platform to iterate, start small and build, leverage reusable modules and patterns, and then to the best of your ability, fail early and fail fast. For us, compliance as code really is part of a bigger picture where we've integrated it within our configuration management lifecycle. So, we audit for compliance, but that feeds into how we codify those security controls and configuration management and configuration as code, which feeds into the integrated testing we do with that and the reviews that are conducted around that, which ultimately, again, produces a version state artifact that we can deliver to systems at scale, which is then in turn audited for compliance, which feeds back in. We found it to be really incredibly beneficial to have our compliance as code to provide insight into changes we might need in our configuration management and our configuration as code, and then vice versa. As we make our configuration as code better, that provide insight into changes that we might need in our compliance as code. When you're creating the Inspect, make sure you leverage the native Inspec resources that can abstract a lot of that technical complexity. So if you're configured or accustomed to Chef infrastructure, configuration management, configuration as code, this probably sounds very familiar. And that is, make sure you use the resources that are there. Otherwise, you're not really gaining a whole lot of the benefit to using Inspec. Part of it does abstract away some of the details. It makes it a lot easier to read by your consumers. And it also can help handle variance in the underlying technologies. We've had great success in using custom resources for scenarios where there is not a native resource available to us. And one of the big benefits is that we're able to better test that custom resource, better to unit test that custom resource, and then be able to reuse it over and over again in a modular manner. As a last resort, of course, you can leverage the actual command resource just to mechanically execute a check text and then examine its output. We have tried to avoid that to the best of our ability. But sometimes there's no other way, or there's no easy way. And what we've found over time is that a lot of things that we check manually or through commands and just examining output, we've seen new resources come available as Inspec evolves, and we can then transition over to that native resource to perform that check. If you do use commands, one thing we'd encourage you to do is keep an eye out on standard error or exit codes and things like that. What we found sometimes is that when we run a command, if we have some kind of typo or mistake, or for whatever reason it is not successful, it can be misleading, if you will, to the rest of the check. So for example, we might have a command block that is finding a bunch of files that we then want to describe what we blocks on, we want to examine. And if there was something wrong in our find command, it actually may come back with nothing. It threw an error to standard error, and standard out contains nothing. So then in turn, we don't do anything, like there's no describe blocks are executed, and it looks fine. And obviously that's a misrepresentation. So we found a benefit to look at that standard error and make sure that we're not getting errors from our command resources. Of course, use logic that the Ruby is available to you to kind of handle more complex cases. Admittedly, the picture I have here is not terribly complex, but it's what I could fit on the slide. But in this case, we want to check a piece of configuration for the GNOME desktop manager if it's installed, and we do. However, if that package is not installed, we can simply skip the control. It's not applicable. So we're leveraging the admittedly simplistic logic that Ruby makes available to us, but nevertheless. In some of our controls, it really gets quite complex and nested in the logic, and we're able to do that since this is ultimately Ruby behind the scenes. Use inputs to provide your consumers flexibility. So this goes back to kind of the solution variability that we have. Something that we found is that for any particular piece of technology, it would be reused in various products, and there might be some slight variation in its implementation. And that variation is fine. It doesn't necessarily invalidate the product from a security perspective. It's just different. So for example, in Tomcat, we would find Tomcat installations and different products that might have a different user for the Tomcat service. And it doesn't really matter as long as everything lines up from a permission perspective and things like that. So we expose that Tomcat user and group as an input into Inspec. And that way our consumers can specify what's appropriate for their particular implementation. And then in the corresponding Inspec controls, that gets substituted in. You absolutely can specify default values, which we try to do quite extensively, just to kind of handle the default case. We also found it really beneficial to sanitize that input. That way, if someone gives an input that is nonsensical or invalid or something like that, it doesn't inadvertently break your Inspec controls in ways that you did not anticipate. Lastly, we really had a lot of success partnering our Inspec developers with various technology domain experts, and that greatly increased the accuracy of our controls. The Inspec developers, my team, we're a jack of all trades. I like to think that we know a lot about a lot of things, enough to be dangerous, but by no means we're not experts in all the technologies that we need to create profiles for. So what we often do is have one of our developers literally sit down with a domain expert and pair program through the profile. And it worked really well. What the developer brought to the table, right, was that their experience in Inspec, the repertoire of resources in their head that they have available to them, the design patterns, the best practices that we learned, and then the domain expert would help fill in the technical gaps to make sure that the control is technically accurate. So now that we have the profiles, the next step really was to be able to orchestrate that at scale. To be able to scaling one node automatically is wonderful, but we really need to be able to audit all the things, right? So a great opportunity here, of course, is Chef Automate. Full disclosure, we ended up not using it as much as we thought we would, partially because we were still on V1 at the time when we went down this journey. So we were very much exploring V2 and excited to kind of learn what it can help us with. And I would definitely encourage you to do the same, because there is definitely orchestration capabilities within it. For us, for the time being, we did cobble together a little bit more of a homegrown solution. There's really two approaches that we've taken. One is a centralized and one is a more of a decentralized approach. So in our centralized approach, we have an orchestrator that is able to gather the Inspec profiles and also be able to reach out to some other proprietary services, such as a password vault that we have. And then from that centralized orchestrator, leverage the remote SSH capabilities of Inspec to actually reach out to the nodes and audit them. As it gets that feedback, it does a little data transformation in terms of formats and then feeds it into our results ingestion reporting platform. Another approach we've had is to have an Inspec cookbook that has the profiles, and behind the scenes is ultimately running the community audit cookbook. And that runs on each node, local to the node, and then runs Inspec locally on the node, and then ultimately feeds those results back into the ingestion and reporting platform. Both have their pros and cons. Both kind of have a different pattern in terms of remote access. So we'll likely keep using both patterns, just depending on the particular limitations that might exist in some of our network segments. One thing I wish we could have done better, and I hope you can take away from this, is to better prepare your auditors to help minimize surprise as you go down this journey and compliance as code. So very much engage your auditors early and help set expectations. So that code, with the compliance as code, it helps shift the evidence burden of the code into the code as opposed to the literal output, right? So as opposed to your auditors checking screenshots over and over again, right? They really need to build trust into the code base. So for example, two checks here. The first one is more of a traditional check where we are running a command line, we're grepping for a piece of configuration and just checking the output, right? In an old world, we would have taken a screenshot of that and provided that onto our auditors. In this new world, we're getting the results from Inspec, and in this case, we're using the default reporter from Inspec, and ultimately, it does tell you the same piece of information, right? But it looks a little different. And a challenge we encounter is that the auditors were not accustomed to receiving the output in this format. So we could have done a better job up front of teaching them what this output's going to look like and helping them better understand just kind of the syntax of it, if you will. Something that goes a long way in that is to try to inject more contextual information into your Inspec output. And we were able to do so through some custom logging mechanisms. Full disclosure, this is not perfect. We think we can make this a lot better, but it did meet the need for the time being. What we created was a module that makes it convenient for us to be able to kind of log additional informational statements into the Inspec output. Behind the scenes, it's ultimately, there's a lot more to it than what you see here, but it's ultimately doing a describe block as the vehicle to kind of get that information into the Inspec output. There is one caveat you need to be careful with this approach, is that because it is using a describe look block behind the scenes, you need to be careful that it does not inadvertently make your control be a false positive. So for example, if you had a describe one clause where you're going to have multiple describe blocks and just one of them needs to be successful for the control to pass, if you had this logger in there, that would make it go true, right? So you just have to be thoughtful in its use. There are a couple of gotchas. We are hoping in time to explore a little more of an elegant way to incorporate this logging, but it did meet the need for the time being. Along the lines of engaging early and setting expectations is very much provide your auditors the opportunity to review and request changes to your code base. We literally gave our auditors all of our Inspec code. And they reviewed every line of it, and it was wonderful. We got a lot of really good feedback from them, and in that back and forth, we're able to help them build confidence in the code base and really have them and us agree upon what the ideal security outcome is, particularly when there's room for interpretation, like in the SRGs where it's a little vaguer. I also encourage you to have clarity and transparency in your software development lifecycle around Inspec. How is it tested? How is it versioned? How is it released? Where do the artifacts go? And what might trigger changes, both internal and external? As a consumer of it, your auditors need to understand how this entity is going to continue to evolve. And then lastly, help your auditors understand the long-term savings that they're also getting. To have our auditors review that code certainly was a large investment from their part, but there was a real aha moment that we had one day where one of them made the comment that in the long run, this is going to save them so much time, because they are coming from a world where they're literally looking at just countless numbers of screenshots and things like that. And by making the investment to look at the code, to review the code, to be confident in the code, they knew that the next time, they got 10,000 results that said these things are all good as a result of the compliance's code, they could trust that, and they didn't have to go examine every single little nitty-gritty little thing, right? So it really, in the long run, can save them a lot of time also. So start with your Inspec reporters and ways to kind of help customize that output for your consumers. There are a lot of reporters out there. JSON, YAML, HTML are great examples. We really had a lot of success, of course, with the JSON reporter as a foundation to then be able to further transform that into other formats. We leveraged some command line tools such as Inspec tools from MITRE that enabled us to be able to further convert those results into XCDS, into checklist files, into CSVs. And it's literally just a command line tool that we can bake into our orchestration of Inspec. So what I like to do is revisit our requirements and kind of describe ways in which we felt that compliance's code and Inspec help us meet the need. So to begin, we had that we must meet or exceed the security posture defined by the DISA STIGs. And in that, we very much were successful. Our Inspec results were used in multiple federal assessments. And in those, as I mentioned, we were able to incorporate a lot of auditor-provided feedback into our test logic to really ensure that we and our auditors are on the same page as to what is the ideal security outcome. Beyond that, we also were able to get a higher degree of coverage. So when you look at things like SCAP, as I mentioned, like for Linux, it really only covers about 3/4 of the controls. But with Inspec and with the customization, with the complexity that we are able to build within it, we are able to articulate even more complex scenarios and be able to get coverage on controls that otherwise would have been considered something that only a human could make an interpretation for. And then beyond that, for many of the profiles, there is no SCAP. There is no existing automation, particularly when it's based on SRGs. And with Inspec, again, we're able to articulate that complexity in those edge cases to be able to get a high degree coverage on some technologies that otherwise would have been entirely a manual audit. Beyond meeting, in many ways, we also found that we actually could exceed the posture defined by the STIGs. So to give an example, in Linux, there is a control around validating that the audit records successfully audit the chmod syscall. And as described in the check text, the control has you grep the audit rules, look for chmod, and make sure that there is an audit rule for chmod. And that's a great start, but what we found as we started creating Inspec for this is that we really could go beyond that. So in the Inspec, of course, we still do look at the audit rule and we make sure that there is the appropriate line in the audit rules. But we also make sure that the audit D service is installed, that is enabled, that it's running. That rule is not going to do us a whole lot of good if the audit service is not running. And then even to go one step further, we use the Inspec audit resource to make sure that the rules in memory that are actually running also contain that rule. And this would catch the scenario where someone has implemented the configuration in the actual configuration file, but for example, has not restarted the node yet, so the audit rules haven't taken into effect. So we're really able to articulate even a security posture beyond just what the base DISA specifies. We asked that the tool be able to provide a framework for manual findings, and absolutely that was the case. The SRGs I mentioned before, they really provide a broad security guidance for a classic technology, but they don't give you pragmatic checks. They just kind of give you a direction, if you will. And the Inspec enabled us to really clearly define our particular interpretation of that control relative to that particular technology, and then be able to use that for auditing. We found it to be really a natural pairing with Inspec. So for example, if you look at the database SRG, there's a control that wants you to verify that the database management system uses the current timestamp values that match the internal system clock. In this case, we're interpreting that in the context of MySQL. And with Inspec and in a combination of some MySQL commands, we can very clearly create a command that clearly looks for the right piece of configuration for MySQL and then check its output. So with Inspec, we're taking a very generalized guidance and turning it into a very, very specific check. We asked that the tool be able to produce results compatible with the federal STIG viewer and also be ingestible by CERNER's proprietary vulnerability database. And this is where the multiple reporters and then some of the conversion tools that we can tack on after that really came into play. So as I mentioned, we very heavily leveraged the JSON reporter, and then using both community tools and a combination of some CERNER internal tools, we're able to convert it to various community standards and some internal proprietary things to be able to feed it into the various databases and consumers that we needed. We want it to be customizable for solution product implementation variance. I guess I won't rehash the input mechanism, but that is really how we were able to achieve that. By using those input mechanisms, we can give the flexibility that we need for that varied consumption. We wanted to integrate into our CI/CD pipelines to be able to help shift that compliance left. And we've had great success with leveraging Inspec as part of our integrated testing of actual configuration management. So for example, on the right here, we have an Inspec audit rule just for some IPv6 settings. And we can run that code then as part of our integrated testing framework that we use with configuration management. We happen to be using Test Kitchen, as I'm sure many of you are. And then Test Kitchen then can validate that the product that what our configuration management is producing aligns and passes the standard that we've set through Inspec. And those two can continue to feed into each other. We're also really excited and just beginning to explore, admittedly, baking these Inspecs into our image building pipelines. So we see a good opportunity as that being a gate to artifact promotion, right? So as part of the image building, we can validate with Inspec that it adheres to the standards that we've set before we make it available to our solutions. And then we wanted it orchestratable across large systems and be able to remotely scan target systems. And really, whether you're doing something homegrown, whether you're able to leverage Chef Automate, the modular design really allows, I think, for orchestration at scale. That is customized to your needs. I mean, ultimately, it's a command line tool, and given a set of inputs, and it will go produce a set of outputs. And we found that there's lots of ways for us to kind of plug and play that into different systems in a modular fashion. So in closing, I would love to leave hopefully a few core tenets to walk away with. First is to use compliance as code as a vehicle to unite all our stakeholders. With it, you can clearly articulate your security posture, and more importantly, I think, is to be able to produce a versionable artifact that represents that security posture. Integrate your compliance as code into your broader security configuration management strategy. So using Inspec, you can leverage that as a way to get early feedback into your configuration management. Engage your auditors early in your compliance as code journey to better prepare them for its consumption. I think it's really important for you to help them build confidence into the code that is auditing the systems. And last, scale beyond humans with compliance as code. Of course, saving yourself and your system owners time, but make sure your auditors also understand the time savings that they're going to gain and benefit from this. And with that, I'd love to field any questions if there are any.
Awesome, dude. That was great. Yeah, anybody who has questions, please use your Q&A panel. It's at the bottom of your screen. I'll start off. I have one. Are you, when you're referring to auditors, are those folks that work for your organization, or are you relying on like external consultants that come in with their binders and all that good stuff?
Absolutely, both actually, which I imagine is probably a fairly common answer. We're holding ourselves accountable from an internal audit perspective, but yes, we absolutely have external auditors who are having to come in and audit us on various contract behalfs.
And do you find a different level of willingness to talk about auditing this way, or are folks like sort of getting on board with this whole idea of sort of compliance with code and that sort of thing across your part of the industry?
Absolutely. We are seeing some variance, and that's per reason I wanted to stress so heavily in trying to engage your auditors and setting that expectation earlier. We would find some who are a little more resistive, or who might have concerns about not being able to understand the code base. That their bread and butter was kind of looking at output, if you will, and checking that output. So the idea and the concept of looking into a code base and gaining confidence in it sounded a little bit intimidating. We've had other auditors who are much more willing to kind of go down that journey and are excited to review the code base.
No, that's awesome. Okay, we've got a couple from the audience here. First one, what factors were used in your organization's decision to use the STIGs versus, say, the CIS benchmarks or something else?
A great question. So we depending on our contractual need, we really have obligations to both. For our particular federal contracts and the areas that we operate in from a federal perspective, we happen to be held accountable to DISA, which is why we have so much emphasis on that. We do use CIS here and there, but it's not nearly as prevalent as DISA within our ecosystem.
And along with that, with the DISA requirements, what tool are you using to convert Inspec JSON to something compatible with the DISA?
Yeah, no, fine. So the Inspec tools, Inspec _tools, MITRE has quite a few, and they have a public GitHub that I'd encourage you to go take a look at. Tools out there. We found that to be really, really beneficial. It can do quite a few data conversions that we needed. So going from the JSON to, say, an XCCDF, which is a fairly common standard, or to a checklist that can be viewed in the STIG viewer, things like that. The Inspec tools from MITRE really is beneficial. Of course, there were a few proprietary formats that we needed internally that we had to go create ourselves, but it was a great starting place for us.
Excellent. Yeah, I posted the link to that GitHub repository in the chat there for folks that are interested in that. The MITRE folks have put together a couple of collections of different Inspec things that are helpful for folks there.
And there are quite a few, I should mention too, there are quite a few profiles out there in the community. We've kind of had, I'd say, mixed results. A lot of those profiles we used as a starting point, as a jumping point, to be able to then kind of further customize to our particular needs. We hope that we can contribute back to them also. But before you go down the journey of crafting something entirely your own, just like is true in the configuration management space, there's a growing community. And I do leverage that community when and if you can.
Yeah, definitely. There's plenty of folks on our Slack. If you happen to be a customer or have a success package, there's folks on the success Slack as well. One more question here. With your auditors, have you noticed a decrease in the amount of artifacts they request because they now have trust in the code as compliance? Has it lowered your burden there? Has it changed how that interaction happens?
Yeah, I think it is slowly over time, and I think it will continue to do so just based on the commentary that we've received from them. Previously, a lot of that auditing would be dependent upon notions of sampling, if you will, right? Because they knew they couldn't reasonably look at artifacts from all thousands and thousands of nodes, right? So it'd be somewhat of a random sampling to try to gain confidence that that sampling represents all the other systems. By doing that examination through compliance as code, we really can move away from that sampling model, and we can check everything because we can do so more efficiently. So that's the hope I continue to see. I think it will continue to do so, and I hope to do so, where we don't necessarily need to gather samples anymore. We give them the entirety of the data, and they have built that trust into the compliance as code.
Well, this one's kind of a follow-up to that, I think. So your auditors are able to understand the Inspec code base versus requiring screenshots. And did you have any convincing to do to achieve this? And how are you storing that stuff? Do you use SIEM, or if it's SIEM, is that SIEM for that?
Well, so it's storing mechanically. I mean, we are keeping this within source control. Our auditors don't have literal access to our internal source control, so we would produce a package that contained all the latest and greatest Inspec that we would provide to them for them to review. We've gotten that feedback often. It's not perfect, but like, you know, in Excel spreadsheets and things like that, where they would you know, for each control, they might add some commentary or some of their thoughts on it, and we would just reiterate across that. We would go up to our Inspec, and it really gave us a way for us to get to a common ground. It definitely did help that some of our auditors were more, they were already sick of looking at screenshots, so some of them had done bash scripts. Like there's been previous attempts to try to make this world a little bit better, so they're a little more receptive to the idea of let's automate this to make all our lives just a little bit easier.
That's good to hear. Like some of the tools are like, oh, some clunky old Java applications, some other strange things are out there. A couple more here. If you have any tips or lessons learned for dealing with unexpectedly large Inspec output, sounds like someone may have gotten many megabytes of things out of a big report.
Yeah, that's an interesting question. One thing that we have encountered occasionally is that you can get a little heavy-handed, I guess, to say with the verbosity that Inspec could potentially give you. So, for example, if you had a directory with tons of files and you needed to check the file permissions of all those files to ensure everything in there is correct. So let's use a user's home directory, for example, and there's lots of controls in the Linux DISA around that. One approach is to have a describe log for every single file that's in there. I mean, you would, of course, systematically discover those files, but that had two consequences that we really didn't anticipate. One is that it is incredibly detailed in its output. Like, that's a lot of output to ingest as it's doing those describes for every single file. And then likewise, it actually takes a while. You know, it's a little bit resource intensive to do that describe block across so many files. So an approach that we took often otherwise is to I guess look for the opposite, if you will. So if everything in this directory is supposed to have this permission, rather than to check every file and confirm it has permissions, use, like, say, a find command and look for things that don't have that right permission. And that is what we do describe blocks on in output. So kind of look for the negative as your trigger to failure. The only downside of that is that it does lend itself more towards using the command resource as opposed to as much native Inspec resources, but it definitely helped reduce the volume of the output and the time it took for some of these controls to check. Does that answer your question?
Yeah, that's super interesting there, I think.
Okay.
All right, next one. Have you had the same success with PCI or any other non-government related audit?
Not yet. We frankly have been very, very much focused on the federal side of things. I hope there's an opportunity to explore there, but the initial journey has been focused on the federal side.
Okay, cool. One more here. This person's worried about the effort in custom development and maintenance of compliance rules. And what's your experience on that sort of issue? You kind of mentioned that you were approaching this as its own project. And like, I know over time, you know, as you change anything that you're testing, obviously you need to update all your tests. But what's your process for that kind of stuff? What kind of burden do you see?
No, it's a great point. It's undeniably an investment up front. I'd be lying if I didn't say we spent a fair amount of time developing this. And again, you know, to what degree you can leverage community created content can certainly help mitigate some of that initial investment. But the life cycle actually has not been terribly bad. So in DISA's particular case, often those profiles are updated on a quarterly basis, and even not necessarily every quarter. I mean, usually some profiles are, some aren't. It just kind of depends on when they have contents. So the triggers, and there's other triggers that might warrant change, some of the things that we discover internally, but they're not really that outlandish in terms of scale. And when they do happen, it's not that bad. So we have internally, we created ourselves a nice little convenient compare tool that will look at the current profile and it'll look at the profile that's just been released and find the delta between the code base. So what that tends to do is it gives us like, oh, here's like the 6 controls where there might have been a slight tweak to the text or to the metadata. And often it's just that. It's just a slight tweak in wording and doesn't even necessarily warrant an actual code change. It does sometimes though. But that delta usually has been something on the order of magnitude that I can have an engineer take care of it in a day or two kind of thing. The ongoing maintenance as the STIGs evolve has really been very, very manageable.
That's great to hear. Anything else from the audience? This is an opportunity to, you guys have Cerner has a lot of experience with Inspec and putting this stuff together. So anybody has anything else? We'll, no. All right. Well, thank you very much for participating. Everybody, thanks for coming.